document understanding tasks, like optimization of information extraction from documents. Because like, okay, fun fact. um, if you go into like the logistics industry, um, they're mostly like still on like processing stuff on paper, like pen and paper. So, um, for example, if you order something, say a bag from China, from a factory in China, and then you want it to be delivered to say somewhere in the US, say like somewhere in New York, there would be like 12 steps along the way where what they do is say like say say a container ship. They would print say the documents that the port would require. They would print it, and then the port authorities would hire someone to transcribe the printed document um into like a digital format, and then they would again print that digitized form, and then send that printed doc to the next, say, to the next shipping uh shipper or something, shipping container or something. Yeah. And then that happens like 12 times from the port of origin to like to the destination. Yeah, it's weird. But that's what basically that's the situation in logistics. If I'm not mistaken, it's because a lot of these companies are like really old, and then they don't want to change things. Like they're very conservative. Like it's just like it's working, so why change it, right? So yeah, there are like a lot of opportunities in document understanding, document processing, and logistics. Um, so yeah, that was my previous job. But like I'm really like a mathematician. I studied like BS math in university. So yeah. Okay. Should we start?
Yeah,
Or
go
how
ahead.
people start coming? Oh, okay. So hello everyone. I'm gonna repeat my introduction. I'm Franz Cesista. Uh, I was a machine learning research scientist at XPDoc. I'm a mathematician at heart. I also did like competitive programming. So if you guys hear shared background. So yeah, I'm gonna talk about multimodal structured generation and and my solution to CVPR's second MMFF challenge. Um, so yeah, so I'm gonna talk about like five things mainly. So first is like an overview of like vision language models or VLMs. Second is description of CVPRs, MMFM challenge. Um, Third is an overview of my approach, multimodal structure generation. Four are the results, and I actually like found like an interesting how do I say this, like phenomenon. But yeah, uh, there's something going on with like VLMs, and then they actually suck at right now. They suck at document understanding tasks. I have four hypotheses why, and then like I have uh, maybe like a solution of some sort. And then later on, I'm gonna discuss like interleaved, like my subsequent work, which is like interleaved multimodal structure generation. Okay, so first, okay, if you guys have like any questions, just message the reading group channel or yeah. So first, there are like three kinds of vision language models or
Sorry, kind of like
oh
in
sorry.
the chat, apparently for some people your audio is cutting in and out. But
I don't know.
I'm not sure if it's enough to. I don't know how much of an issue it is. But sorry, people are typing in the. Okay.
Okay. So just let me know, guys.
Yeah.
Should I do something?
Uh, okay.
Maybe I should
People are
lower
saying
the.
it's not an issue. Maybe. Sorry. Sorry for interrupting. Yeah. Okay.
Okay, it's fine. All right. Okay, I can't actually see because I only have like one screen right now, and then I can't see the chat. Okay, uh but yeah, but just tell me, just interrupt me, guys, if you have like questions and stuff like that. I'm gonna do a Q&A later. After like everything, I'm gonna breeze through like a lot of things, cause like yeah. Um, so yeah. So first, I'm gonna like as a refresher for some people, and like an introduction for most maybe. So there are like three kinds of vision language models, and then it depends. Basically, like we can characterize vision language models based on where the interaction between the modalities like happen. So, for example, like if the interaction happens yeah, basically it's either like the interaction between the text information and the image information happens before the encoder or within the layers of the encoder or like after the encoder. So yeah, so first is like the first type or early interaction VLMs like chameleon. So yeah, so models like this typically have like tokenizes like everything. The images, text, videos, like audio, they tokenize everything, and then they use like one embedding layer for the tokens, like just one single um embedding layer. So that this is why they're called like an early interaction, because like they're only like using one embedder. So yeah, so the next type is cross interaction VLMs like Llama 3.1, the latest one. Like this was like published 3 days ago. Um, so so yeah, if you could if you could follow their chart, basically there are like two towers or like separate towers for each modality. So there's like an image encoder, a text encoder, video like encoder, aggregator, stuff like that, and then they mix the information using cross attention. So yeah, so it's either every layer or like the most I found was like they mix information per layer. But here they're mixing the information like every fourth layer. So yeah, these are like cross interaction VLMs. And then the most common ones are the late interaction VLMs, where like they use separate encoders for each modality. So for example here, like there's like an embedder for like the text, and then there's like a separate embedder for images. Like it's a separate code path, and then later on they're just concatenated and then fed to the language model, and then voila. Um, yeah, this is what I actually used for this challenge, like Lava. So I think of this as like grafting. Like if you're grafting plants, right? Like you want to mix, say like an apple tree with say like a branch from an orange tree. You can do that, and then it's just like that. You're just like cutting off a branch. Like here, it's like you cut off the encoder and then you graft it to an LLM. Then voila, you have like an vision language model right there. So yeah, okay. So yeah, a month ago I participated in CVPR's second MMFF challenge. Um, Instead, the question was the main question basically was like, do these kinds of models do multimodal foundation models or basically like vision language models still suck at document understanding tasks? Because like yeah, it's 2024 and they still suck at it. Yeah, spider. Yeah, they still kind of. Um, yeah, there were like two phases. The first phase has like entirely public document understanding datasets. These are the most common ones. So if you're gonna publish a paper on document understanding, you should at least test your model on all of these datasets. So docvqa, funsd, and stuff like that. So these are the most common ones. Um, yeah, and then phase two, which I think was more important, has three private test datasets. So the first was my doc. So they look like this. So questions were like, okay, given this image, what is the address one in the image? So the answer here would be like address one AMP media. So these they look like FunSD documents, but like more dense. It's like fun is I don't think FunSD is actually like a good data set test data set because like the documents are kind of sparse. They don't like they're not as dense as this. So yeah. So this is like my doc. Second is my chart, which look like chart VQA. If you guys have look into that dataset. Um, questions are like, can you explain where the income from discontinued operations like 0.01? So for questions like this, it's not the text is information is not enough. Like for example here, you have to look what income from discontinued operations. That's like the yellow bars. Then you really have to look. Yeah, like if your model is blind, it's not gonna perform well in this dataset. Um, yeah, and then the third one is my infographic. So this is similar to infographic VQA, but like they added infographics from like other languages. So for example here, like yeah. So yeah. So next third we're breezing through. Just tell me if like I'm going too fast or something, or if you guys have questions, we're gonna discuss it later. Um, but yeah. So for context, I actually joined like this challenge was like they announced it like months before, but I only saw it like 48 hours before the deadline in LinkedIn. Um, and then like I wasted like more than a day working with like commercial models like and apparently they weren't allowed. So I had to spend like the remaining less than 24 hours converting everything to like open models, open inference script and everything. You can actually access the my codes in this like GitHub link. Like all of them are there. All of my codes are there. Just go there. Yeah, so and I did not have like a really good GPU. Like my laptop is like around 5 years old or 4. I don't remember. So yeah, and then I'm on a student budget basically. So yeah, this is me. During like the entire 48 hours, I had no GPUs, no money, no time, no nothing, no sleep. Um, so yeah, I couldn't do fine tuning because like I didn't have GPUs, and then I couldn't do like I couldn't implement RAGs, like retrieval augmented generation. These are it's like if you're gonna make an ML system, you have to implement these like to maximize the performance. But like I couldn't do any of them because like yeah I didn't have like the resources. And yet I managed to like to place second in the head and test set. So yeah, how? Um, in short, I use like multimodal structured generation. Where like the gist is that say if you want to output like a JSON object or something parsable by a regex pattern, when you're generating like the output, like say like when you're generating an output like the model outputs logits, right? Um, if you encounter like invalid tokens, just zero them out. Just zero the probability of like invalid tokens. Like yeah, if you're 100% sure, let's say you're generating a JSON object, right? If you're 100% sure that the next token is like a close parenthesis, just zero out the probability of like all the other tokens, or just generate the or just output the closing parenthesis, and then that's it. So basically, this is the gist of multimodal structure generation. This is kind of like tool use with GPT, but you're 100% sure that the output is parsable by downstream APIs. It's like um, so yeah. So why? Basically, I used multimodal generation to force the models to reason before answering. Or, well, they don't really reason, but like to give them like some sort of a scratch pad before answering. So, for example, here, you can actually pass this to like GPT-4, like tool use API, and then like ask them, basically like ask it to reason first, and then before answering. Yeah. What's nice about using open models and like libraries like outlines is that um, you can actually force the models to like have a minimum like number of tokens before, yeah, like reasoning tokens, something like that. So like here, like I'm forcing it to output 500 reasoning tokens or like draft tokens before generating the output. And then yeah, and then um yeah, you can pretty much like force it for force what kind of output you want. Yeah, and then like I'm not actually the first who thought of this, because like the team at Outlines actually already did this like a month, like 2 months, or like a month before me. So yeah, credit. um so yeah, so this is what I did. Basically, like I used Lava 1.6, which I discussed earlier, was like a late interaction vision language model, and then uh, I used like structured generation to force it to reason first before answering. So it performed well on my chart and my infographic on these two data sets, but not so well on my doc. Yeah, I'm gonna discuss the difference earlier. So yeah, for my doc, I had to revert to an LLM, like which is like a fine-tuned version of Mistral. Yeah, it's this model on Hugging Face. You could access it there. You could download it there. This is really this model, like which I fine-tuned myself, is like really good at extracting information from documents. Um, so yeah, so why did I have to revert to an LM? So okay, let's review the literature first. So okay, so in a document there are three kinds of information you can extract from it, right? So first is like the textual information, like the text contents, um, or say like the vendor name or stuff like that. Second is like visual information, maybe the charts in the document or like whatever are in the document, and then the third is the layout information or like the bounding boxes, or basically where the stuff are in the document. So yeah, there's this interesting paper where like they removed the vision encoder and then treated the like bounding boxes as their own modality. And then like they found that it didn't actually hurt the performance. I would recommend reading this paper because like this basically crosses out like basically for document extraction, like dense document extraction, like the visual information may not be that important. Um, they claim. And then building on that, or more like yeah, in our like we in our work in our previous work, we also found that um removing the layout information, basically removing the bounding box information, doesn't harm performance either. at least for like for key information extraction. Uh, yeah, you could read the distinction in our paper. But yeah, basically key information extraction is basically the task in FunSD. Like extract this, extract that. Um, um, the other task is line items recognition, which we also analyzed. For line items extraction, the layout information still matters, but for KEI, it's not. It doesn't matter. So we're left with textual information. So what we basically found was that for dense document extraction, the visual information and the layout information don't matter at all for this specific task. For the task like my doc, yeah, you only need like an LLM for that. That's why like if you guys have already used like instructor or those other libraries for like automating like RAG and stuff like that, they work well despite only using LLMs because for this specific task it doesn't matter. I'm gonna discuss this like later on. Yeah. So yeah, here are the results. So yeah, this is me. Out of like 81 participants who registered, there were like five like who were qualified at the end, if I remember correctly. So yeah, this is me. Um, I got like second place out of like all the participants, and then like this new benchmark. Because like I was the one who coded this. This is also in my GitHub or a GitHub like repo for this challenge. So you can find the code there. Um, so yeah. So these are the results. Yeah. For my doc, I had to use like an LLM, and then if I use like a VLM, I only got like 21%, which is like a lot worse. Like 300% worse or something. So yeah, this is what I want to discuss actually, because like I've been thinking about this, like why did like an LLM outperform like a visual language model on the MyDoc dataset? So yeah, like I have like four hypotheses why this is the case. So the first is that yeah, like as I discussed earlier, like the visual and layout information are not important for key information extraction, which is basically like this task. Like my doc, like the my doc dataset is like key information extraction. And then like from our paper, if you can see here, yeah, it like structured prompting, like the structured prompting here is basically we were infusing the layout information into the prompt, so that's like structured prompting. And then the perf gains weren't that big. Yeah, basically it doesn't matter like you do this or not, you're not like barely, you're gonna get like barely not that big. So that's the first hypothesis. Like yeah, for KAI, like you only need text information. And then the second hypothesis is that you don't need the layout information because for like the exact bounding box coordinates, like you don't need the exact bounding box coordinates for this task, because maybe the LLMs could already like infer the location of the words from the index of the prompt. Like for example, if the word is somewhere in the middle of the prompt, then we know that it's somewhere in the middle of the document, right? If it's somewhere in the beginning of the prompt, then we know that like it's somewhere at the top of the document. So yeah, so that's like the second hypothesis. That maybe like yeah, this the findings in this paper applies in the 2D case. the third hypothesis is that like the vision language models are just like at overcapacity. Because like the LLMs are already like trained like at capacity, based on like neural scaling laws, right? And then like we're gonna graph the vision encoders on top of them. So yeah, that's the third hypothesis, and then the fourth, which honestly I'm most convinced of this, is that we're not using enough image tokens. There's a troubling trend, I believe, that like uh, there's like a lot of research going on right now where like they want to reduce the amount of like the number of like image tokens being fed to like to the language model. But I don't think that's the right approach. It's like there's this interesting table from the paper Matryoshka multimodal models where they basically like measured the optimal number of tokens for the maximum performance. And then if you look at like doc VQA, it requires like a lot more tokens than like science QA or AI 2D. So yeah, so for this, I believe like we're just like we're trying to compress like the visual information into like so few tokens, and then that's hurting the performance. So yeah, so as a call to action, maybe like maybe the reason why multimodal models or like vision language models are struggling at document understanding is that they're not using like more image tokens. So yeah, so maybe we should fed them like more image tokens. Um, so yeah, that's basically it. That's my presentation. I could also like do which should we do first, the Q&A or like a demo of like
Oh,
a subsequent work?
whichever you want, honestly. Yeah. Uh, yeah. Yeah, go ahead, go ahead.
Okay, there's a question here. Um, how were tables fed to the LLM for my doc? Oh yeah, for this actually like I used I used like an open source OCR to do an OCR, and then just fed the OCR, the text from the OCR to the LLM. I think that's it. And then it outperformed Lava. Yeah, does that answer your question, Yash? OCR with bounding boxes, no. We just like we discarded the bounding boxes, just the OCR, and then just plain OCR. So if I'm gonna rewind to this page. So if you can see the structured prompting, can you guys see the table? Um, no.
Yep, I can see it.
Okay. So if you guys can see that table here, we have like structured prompting, right? So what we did in the structured prompting is that like we added like white spaces so that the text prompt would look like the original document. We basically like padded like lines so that they would, yeah. And then it didn't like it didn't it didn't like add um it barely added like performance gains, but practically zero. So yeah. Um yeah, at least this is for my doc. And then actually like I've been thinking about this. I'm not sure like how obsolete my findings are, given like how fast new models are like getting published. Isn't that non-efficient? There are like extra um in terms of yes, it's very inefficient in terms of tokens. So like our recommendation basically was like don't don't do this. Don't do that because um you would just add extra like inference time for no gains basically. Uh, would this method work for computer vision tasks? Uh, which tasks? Okay, for my chart and my infographic. Um, from my tests, they doing this on like you just using LLMs on my chart and my infographic. Like they performed worse, slightly worse. So yeah. But for my doc, yeah, it was like a weird finding.
Sorry, one question. So I can understand why this method will perform better for my doc since it's like almost purely text. But like, if there's a lot of information conveyed by like graphs or like a pie graph or something, does this method still like perform well?
Um, for if yeah, for documents with a lot of graphs, maybe not. But like in practice, this actually like I can attest to this. Like in practice, this performs well. Like just using LLMs, uh, performs well. Just like um, back at XPDoc, yeah, basically that was like yeah, it was like a weird thing because like we tried replacing the LLMs with like vision language models, and then they performed worse. So that's probably yeah. But yeah, in practice, I found that like for example in logistics there like the documents are like mostly text or mostly like table-ish. So yeah, you don't have to worry about like having way too many graphs. But yeah, if you have like a data set with like a lot of graphs, then yeah, maybe like using Lava would work. But if not, just revert back to LLMs.
Interesting. And I'm also a fan of your previous paper of like the RAG one, but like
Yes.
for RAG one, like do you mainly do RAG over the image hashes and stuff so that you get like the similar documents with like a similar structure kind of thing?
Yeah. Yeah. For our previous paper, that's what we did. Here. Oh yeah. For our previous paper, yeah, we use like hashing, like image hashing, for um for like RAG, like retrieval augmented generation. Cause like it actually performs really well. Like when you're building machine learning systems, like the simplest approach is usually the best. Like for example here, like if you wanna do like a retrieval augmented generation thing, just use like image hashing. Like yeah, like wavelet hash should be enough in most cases. Um,
Interesting.
yeah, how would you compare
I have a
the?
question.
Yeah.
It seemed like from reading the paper that it was at a conceptual level, what you're doing, it's similar to like internally forcing chain of verification or a chain of thought prompting kind of, but taking an internal approach. Is that accurate? Is that an accurate way to think about it?
Yeah. Yeah. This is like chain of thought, but like you can, yeah, you could control like how many tokens like it outputs. Like even if it's not done thinking, if like if it has generated like the enough tokens you want, you end the chain of thought and then answer directly. So yeah. Yeah. This is like I think the advantage with like using like structured generation is that like you could control for example, like later I'm gonna introduce like like an interleaved multimodal structure generation, and then yeah. Should can we go to that or oh wait?
Yeah, I'd love, and I was just gonna say I'd love to see the demo before we close, if
Yeah.
that's possible.
Yeah,
All
go
right.
ahead.
All right.
And thank you for your thank you for presenting this, by the way.
Oh, thank you. All right. So questions. Uh, um, one shot prompt. Be different for. Oh yeah. In our previous work, basically like for RAG, we basically just fed um our like our input and then like the expected output as like some as examples. It's like yeah. So the input was like the text OCR, and then the output was like the JSON object. Like yeah. So yeah. Okay. So I think okay. I could now move to demoing. Okay. I'm gonna share my. Okay. So yeah. For this one, actually recommend going to this repository because like everything's there. Um. Okay. So yeah. So yeah, the natural extension to this is like so in structured generation, if you don't want to generate if like if you don't want to generate or like if you encounter invalid tokens, you just like zero out the probability of those tokens, right? So the natural extension to this is basically like if you want to generate like a JSON object where like the contents are like images, text, or audio or video in like a mixed format. It's like right now, like I think right now most providers don't do this yet. They don't. You can only get like structured format in like text, but not like this. If I remember correctly. So yeah. So the idea here is that like in like truly like multimodal structured generation is that um like in Chameleon, like the model like Meta's model like Chameleon, it internally it implements like a finite state machine to switch between like text generation and image generation. So like yeah, it has like an internal finite state machine. And then like the natural extension is like why don't we just like use like a custom state machine where like if say like okay you're gonna generate like the fruit name, and then when you start with the image, basically like when you wanted to start generating an image, just zero out the probability of the text tokens. um yeah oh yeah I used outlines yeah internally for implementing the finite state machine. Yeah. So yeah, this library of mine is on the like multimodal extension. Later I plan to like integrate this to the outlines library, but yeah. Um yeah. So yeah, so the main idea is like okay, if you want to generate an image, zero out the probability of the tokens of the text tokens. And if you want to generate text, zero out the probability of the image tokens. And then yeah, that's basically it. And then you could use this to like output stuff like this, like, yeah. As an example, actually run this earlier. I'm gonna share my here. Okay. Yeah. It yeah. So yeah, so this is the response, and then these are the image outputs. The images are lower quality because like I'm printing them to the terminal, but they're like this. Yeah. So yeah. Yeah. So moving forward, I plan to actually like this. Actually, this approach works for any autoregressive model. Like right now, I've only tested it on like Chameleon, for like early fusion or early interaction VLMs, but this should work on pretty much all of them, or even like Whisper plus like text. It's like the main idea is like super simple. Like, okay, if you want to start generating like audio, zero out the tokens for like the non-audio tokens, and then if you want to stop generating audio, just zero out the tokens for the audio. It's just like that. Yeah. So yeah, do you guys have questions? If you guys encounter like problems like running the library, just tell me.
Oh, this is a question from like a fan of outlines. Kind of like in your structure gen stuff, I notice you use like JSON schema a lot, and like and I think for the reasoning step, you try to like make the reasoning generate first by like making it like one reasoning and then two the actual steps and stuff. But like I was wondering, why don't you like just do like I don't know, like stop at, like use the stop at keyword to generate until like a certain, until like, I don't know, like a chain of thought, like React kind of like until.
Oh yeah.
Yeah.
You can actually do that straight with like outlines. Because like what you can do is okay, so okay, I'm gonna share like another. I'm just gonna. So it would be like better. Okay. Can you guys see my code? VS Code.
I see the Discord.
Like here. So if you wanna do chain of thought, yeah, and then chain them together, and then like say have force it to generate like.
Sorry, I think we are seeing the Discords. Sorry, I think we are seeing the
Oh, Discord screen. Oh, oops, sorry. Okay. Here. Can you see this?
Yes.
Okay. So you can also do something like this. Basically like copy paste these, and then say like you want it to generate like exactly 500 tokens before, like say responding to that chain of thought or something like that. So the advantage with like libraries like outlines is that you could force it, like if you like you could force it to output like the exact number of tokens you want, or say like if you don't want it to like generate like 20,000 of chain of thought tokens, just force it to like output a maximum of like 500, stuff like that. So this is the advantage of yeah.
Yeah. Is it like didn't need to
Um,
generate in that order? Yeah.
I with like these like prefixes, the one two three, because like the older version of outlines, like orders the keys by like alphabetical order, but the newer version you shouldn't have to worry about this. We could remove this, yeah, but yeah, it should generate in the proper order.
Awesome. Thanks.
Yeah, and then so the advantage is for this one, for this output here, like generate fruits and then related fruits. I actually used this JSON format. So yeah, like okay, so generate like a fruit name in like of type image, out type string, sorry. And then generate an image, an image of the fruit, and then generate like an array of images. So you could do something like this, or you could say force it to like to imagine like a fruit first. Say uh say like draft tokens. Okay, we force it to generate like 500 draft tokens before generating like a name of a fruit. And generate like 500 imagination tokens. Something like this. You could do something like this, like generate like 500 image tokens before generating like an image, stuff like that. So yeah.
And
So
you,
this is like
you
the
support
advantage of
captioning, right?
captioning.
Can this do
Yeah,
image
if you want,
captioning?
yeah, if you want to do image captioning, just delete these, and then oops, caption.
Oh, cool.
So you could do something like this, or if you want it to like, okay, you want it to reason first. Say draft tokens, something like that, and then force it to like maximum 500 tokens. So yeah, and then voila. Yeah. Or say you wanted to imagine first, like, and then image. So here it would generate like draft like 500 draft tokens, like text tokens, and then um generate like an image of like whatever, and then finally generate the caption, stuff like that. So you can do stuff like this. Actually um I haven't run benchmarks on this yet, but yeah, you can do stuff like this. Very versatile. Oops. Um. So yeah. What else? Actually, like, I would need help running benchmarks because I don't have like GPUs. So if you guys have like spare GPUs you want to get used, like please tell me. Yeah. So I'm gonna run stuff like this. But yeah, this greatly simplifies like stuff like draft tokens, chain of thought, stuff like that. Just specify like the structure of output you want, and then that's it. And like or in the future we might have something like I don't know, like we wanted to generate audio, like type audio. This is possible. Yeah. So to do this, we just like zero out the probability of the non-audio tokens when we reach this spot, stuff like that. Yeah. Yeah. So yeah. Everything should be in my like GitHub repositories. There. All of my codes are there. Yeah. If you guys encounter like problems running the stuff, just tell me. Or raise like an issue. Interesting question.
Hi. Please, is it okay to jump in?
Okay, go on.
Awesome. Yeah, thank you so much for this presentation. It's been very, very insightful. I just wanted to just agree with your hypothesis number 4, when you said that maybe the reason the visual information had not been helpful is because it's not enough, right? So I think, as you correctly surmised, right, for both the early stage and the late stage, the like the image features are being compressed into this really small state. So like in the initial states you mentioned, you tokenizing the image, using C tokenizer, for example, it tokenizes into this 32 different tokens. And also in the late stage, like the clip, like the lava method, which uses clip, it sort of just breaks it down into this patch embeddings, right? So those are ideal for like capturing the semantic information in standard images, but maybe not so for text. So while we're on this call, I did a tiny little experiment. I used the C tokenizer. I gave it a document image to tokenize. I then decoded it to see what comes out, to see how much information it captures. So I can just share those images in the chat just to see.
Okay, thank you.
So the left side is just the document image that was given, and on the right side is what was decoded. So as we can see, so even though it sort of got the structure right, it did not in any way. But yeah, that was just my thought, just to agree with your hypothesis.
Yeah. This is like what I found. Yeah, like they suck at basically like keeping information. So like stuff like this, like we're trying to compress this entire image into like a few tokens, and we lose like a lot of information. And then yeah, as Sage said, this is the reason. Thank you for raising this. Yeah, but yeah, this is I believe this is why they perform really like badly on document datasets or document like tests. Yeah, they discard so much information. So
Sorry, I also wanted to add as well. I'll share the link once I find it. There was a paper that was released, I think a month ago, where they said that they are able to achieve 100% reconstruction. I haven't tried that out yet, but if that is possible, if that is correct and it works better here, then who knows? Maybe it will work well with, for documents.
I'm assuming they're using like a lot more tokens or a lot like yeah. So useful for web scraping. What do you mean by like by that? Oh yeah, for web data. For web data set. There are like a lot of like graphs for like web pages. Wait, sorry, Alkenon. I'm not. I probably don't understand your question very well. Screenshot. I haven't. Like you mean like text and image? I'll retrieve a piece of text. Oh yeah, if you want to do like retrieval of like a piece of text from a web page or like a document, just use like for now use like LLMs. Visual language models are like bad at this sort of thing for now. Yeah. This is based on like information from a month ago. So I'm not sure if like the models right now are like better at it, but like if you want to like extract like a piece of information from a web page or a document, use an LLM for now.
So just for an overall conclusion, for like business like document understanding, the best results just come from like OCR and LLM, basically.
Oh yeah, for a specific data set, yes. For a specific type of problem. Oh yeah, so okay. Oh yeah, it's almost 1 hour. Sorry guys. We're almost like done. So yeah, as a sort of conclusion, if you want to do like a document understanding, if you have like a lot of text, like very dense text, right now the best approach is to use like an LLM, like OCR, LLM, and then structured generation. And then maybe you could add in like at some point like a RAG or fine tuning. But yeah, if you have like a dense text, use LLMs. But if you have stuff like charts or like infographics, then that's the time you should use like visual language models. Um, that's the SOTA state of the art as of a month ago.
Awesome. Thank you so much for the presentation. Does anyone have any other questions? Feel free to like raise your hand or ask a question.
Take care, everyone.
Yeah, thanks for coming. Even if you have a cold, and hope you get better. Oh, actually, somebody raised their hand. Yeah.
Hello. Am I audible?
Yep.
Okay, so I wanted to know in that point that you made that you intentionally left out the visual information. What if there happens to be an image which is presenting a certain sort of information, but the corresponding text is missing? Then how did you make it out of the situation?
Pardon. So, did I understand that right? That like, say you have an
Yeah.
image, then you do an OCR, and then there's like missing text. Is that?
Let's say for instance that you have an image in your document, which is a pictorial representation or a graph or maybe anything, but the corresponding text to that image is missing. How did you deal with the situation?
For that, I doubt like a pure LLM approach would work best. Maybe like, oh yeah, for that I would use like VLMs, visual language models. But yeah, oh yeah, another like as a form of like conclusion, open source visual language models are still like a lot worse than like commercial ones. That is like at least a month ago. Yeah. So
Also, yes. No, I was trying to say that also these models have a problem with hallucination. So
oh yeah.
it might appear that hallucination might affect the performance in both the cases using an LLM or a VLM.
Yeah. Yeah. So structure generation is actually like one way to avoid hallucinations. Because like um you already know the kind of output you want, right? So if you encounter like invalid tokens, just zero out the probability of those tokens. So just use like structured generation if you have basically if you want to pass the outputs of your model to an API or like to a downstream system, just use like structured generation or like tool use API and stuff like that. So that's to avoid hallucination. Structured generation is awesome. And then hopefully like in a few months we're gonna close the gap between like open models and like commercial models. But right now like open models are like a lot worse than so my going back to my slide on performance. There's still like really the my approach with like GPT-4o here actually like also does like uses like tool use. Yeah. I use the same schema basically. So like first step, force it to reason and then force it to output. The advantage with like open models is that with open models you could force it to output like the exact number of reasoning tokens you want. Because like I've encountered problems with like GPT-4 or GPT in general where like they just generate like thousands of tokens of like thousands of useless tokens, which is like what the heck. With like open models, you could at least stop them. Like if they've reached like 1,000 tokens, stop generating, stuff like that. Yeah.
Thank you.
Just confirming, but for outlines, like the performance, they kind of like it takes a bit more RAM and like computing power for like length constraints, right? If I remember right.
Yeah. That's one thing I've noticed. Cause like, that's an interesting question. Like, Chad raised, which is like the memory constraint. Cause like, if we're gonna do like structured generation, we have to build the finite state machine, right? So to determine which tokens are allowed, which tokens are banned. And sometimes, like if you generate like, if you add, say like minimum or maximum length constraints, you're gonna blow up the FSM, that finite state machine. Sometimes you're gonna have like thousands of nodes in that finite state machine. Right now I'm not sure if there's a way around it. But like, if you look at my like repository and MMSG, like I did a trick there where like I combined all of the image tokens into one equivalence class. So just like one node for the image tokens, and then so that prevents the FSM from blowing up, and then
I see. So like instead of all that visual token vocabulary, like instead of having all those FSM nodes, you kind of like shrunk it by like 1,000 or so, right? Just
Yeah.
I see.
So because like my first approach, actually this is like an interesting problem. I recommend like if you guys are interested, like I recommend going through my repository because like this is an interesting problem. Because like the problem with like multimodal structured generation is that like there are like for example here for Chameleon has like 8,000 image tokens, and if you have like a minimum length constraint of like 100, you're gonna get like 800,000 nodes if you don't shrink it. Yeah. So actually that's the first time I tried that, like my PC shut down. It's like accidentally generated like a lot of nodes. I managed to solve that problem by treating like the image tokens as like one equivalence class of tokens. Yeah. For the implementation, I recommend going through my repo. Uh, Oh yeah. There's a question here from Nomia where it's like method for chain of thought. Um, yeah. You can do chain of thought with this. It's more of a superset. Like you can use structured generation to do chain of thought or other other structured like outputs. Yeah. If basically like if you know what kind of output you want, you could do it with structured generation. Yeah. So like what other approaches like chain of thought or draft tokens? You can do that with the same. Okay. Thank you for the question.
Thanks for presenting. And yeah, does anyone have any more questions? Okay, well, thanks again for presenting. And yeah, I think for the next presentation, it'll be by Arthur, who kind of like given an image, transforms it into like spatial sound or something cool like that. But yeah, overall thanks again, Franz, for presenting. And he's pretty active on the outline server, so if you guys are interested in like structured gen, that might be cool too. Yeah.
Yeah. Yeah, you can find me in like Outlines channel, Discord server, or here. Like I'm gonna be active here from now on. Yeah, so if you guys have any questions, just raise like an issue, a PR, or just email me. Yeah, my contact information are in the slides and in my repos. So yeah, thank you again. Thank you so much.
Thanks again, and hope you all have a great day. Then I will end the event.